moving ahead because we're going to take this question a little bit further, and I have the pleasure of introducing Professor Jennie Pryce, who's the Program Lead at Dairy Bio Animals Program Computational Biology Group at AgVic Research. There's little I can say actually about in terms of Jennie's been there, but I think the fact is that Jennie is a geneticist known for work throughout Australia, throughout the world, and to have someone who's been such a significant contributor to the advancement of in Australia, but also internationally in the innovation in the genetic space is a wonderful resource that we have here, and someone who I think takes genetics and makes it understandable by everybody. And I think that's also a really important characteristic, because sometimes, you know, it can just go over your head. Well, Jennie brings it to everyone so they can understand what's happening. So welcome, Jennie. Role of genetics in creating a sustainable future. Thanks.
Thank you. I'd like to start by thanking my co-author, who's Chaley Richardson, my former PhD student. I've actually got 5 PhD students in the room, so can you please stand up, PhD students? 5 out of my 7, so please have a chat with them at lunchtime. It's great to have that. Now, everybody else stand up. You're not a PhD student by standing up automatically, so please stand up. Stretch your legs. So, first question, stand up. First question is, who's watched any TV this year? Sit down if you haven't. Okay, has anybody not watched Channel 7? So sit down if you haven't watched Channel 7. Quite a few, okay. Quite a few people like Channel 7, interesting. I can see some really quizzical looks. Now, has anybody seen this programme? Sit down if you haven't, and remain standing if you have. I thought a few people would sit down. Interesting. We've still got a few people in the room who've seen it. I don't know if you've seen episode 1 of Series 7. I hadn't actually until quite recently. Season 7, episode 1, which aired in mid-February. Now, I don't know if you can read quickly down the bottom right corner. You can sit down, sorry. I'm not going to make you stand up for the whole presentation. It says something about meet scientists working towards breeding environmentally friendly cows. Channel 7, the wellness programme, where I also learnt the pandemic has made us kinder. A new malaria vaccine is on the horizon, and what the colour of a blue emoji is. Does anybody know what the colour of the blue heart emoji means? It means trust. I used it for the Ginfo farmers yesterday, trust and respect. And it's also bromance. So there you go. So, back to Channel 7 and the wellness programme. I know that you're really intrigued. So was I when they asked me to speak to them in November. So I was a little bit sceptical. I wasn't quite sure what sort of spin they were going to take on it. It's only short, so here it is. Jennie on the telly. Can you press play for me? The ideal cow, from a farmer's perspective, is one that converts feed into milk in a very efficient way. She's always healthy. She gets in calf because, of course, cows have to have a baby every year to be able to produce milk. It actually so happens that breeding for a lot of these traits is also a great thing for the environment as well. We want the cows that are able to convert feed into milk most efficiently, and we also want the ones that are able to produce less methane per unit of milk produced. So it's actually kind of a win-win situation. We match the records that farmers keep with DNA, and we get the DNA mainly from tail hairs that we take from the cows, and we extract the DNA from that. And using the genomic technology, we're actually able to work out which cows are the most efficient converters of feed into milk. We're also able to measure individual methane emissions as well, which is a much more challenging thing to do. But that kind of data is incredibly valuable for us to tackle this problem of reducing emissions and being able to reduce the ruminant contribution to global warming. So there you go. Catch it on the Wellness Channel, Fridays at 2 p.m. and Sundays at midday. So yeah, I think it's just amazing to have that on mainstream TV. But yeah, I'm pretty pleased the way it's turned out. And I'll come back to some of the comments that the presenters made at the end of my presentation. So what sort of things can we do to breed for reduced methane emissions? Well, I mentioned a lot of them in that video clip, so I won't recap, but there's a lot that we can do in terms of longevity, feed efficiency, selecting for methane directly, which is the really hard thing to do, and to breed for higher producing cows. So of course we've got ticks on many of those already. So we already have a great news story, and Thuy Nguyen will talk in much more detail about the sustainability index, which already captures the weighting that we have calculated to support reducing methane emissions through the current breeding values that we have. So putting more pressure on milk production, traits, survival, and so on. So if you want to measure methane at pasture, what do you have to do? Well, it's a pretty difficult task. These photos, you may have seen this equipment before. This is from our Ellenbank farm in Gippsland, and it shows the equipment that that is for the gold standard way of measuring methane. It's like a backpack device, and you can get that individual methane measurement over about a 4 or 5 day period. Now, it is incredibly costly, it's very labor intensive, so we have only done a reasonably small number of cows to date, 500 cows, all from the Ellenbank farm, because of the type of equipment and the sort of technical support that we need. We've also collected a lot of rumen fluid, I'll come back to that later, and also other information on those cows. So we've got a really rich data source. Now, my colleagues at Ellenbank are the global leaders when it comes to this SF6 method for measuring methane, and it is our absolute gold standard here in Australia. So, given the way that we can measure methane currently, this is the kind of pathway to generate those real methane breeding values. You measure in those research herds, you develop your genomic prediction equation, and then you apply that to the population in which you want to select. However, the challenge and the problem with it is that because we've got a small data set, the accuracy or the reliability that we're able to predict that methane is very low. So this is work that Baloma Sundimajit did, and it's pretty much in line with what we would theoretically expect for the size of reference population. If I took this breeding value to the Data Gene Genetic Standing Committee, there's no way it would get off the ground because the reliability is too low. So we need to go much bigger. We need much, much more data. So the things that we can do is that we can share reference populations. We work internationally to bring in data from other places. We can look for indicators of methane, like, for example, potentially mid-infrared spectroscopy, or we can use sensors, either wearable devices or things that we stick in the parlour. But you always need to compare whatever the proxy or the measurement is to the gold standard. And in our case, for methane, it's this SF6 methodology. So it's pretty exciting, actually, because right now, I think it's day 1 today, we have an experiment happening at Ellenbank to test a variety of different technologies, especially in the sensor space, and comparing that to our gold standard methane, or SF6. And the idea being that we can then take the best of those measurements to the next stage, which could be measuring in the gigahertz. Now, I was asked to take a bit more of a global view as well in terms of what everybody else is doing in this area. And I'm really happy to tell you that there is an immense sense of collaboration internationally through animal geneticists. And the International Committee on Animal Recording actually has a working group which is called Feed and Gas. Beautiful name. And the focus is on measuring methane and how we can work together to get the best outcome. So there's a list of names on that working group. So I'm on it, for instance. Michelle's also part of it as the industry liaison. And it's a great place to actually start to think and to be really open about the ways that we can measure methane on commercial farms. So I'm just going to take a few examples here, a bit of a trip around the world to see what's happening in New Zealand, Canada, Italy, and the Netherlands. So let's start with New Zealand, who have purchased these green feed devices that are very popular around the world for measuring individual methane. Now, they are actually measuring methane in bulls, and this is, I should say, a partnership between CRV and LIC. And you can see there's a bunch of different organisations involved. This is just a few photos to show how they're measuring the methane and their sort of trial design. So they're looking at a 35-day window. But their focus is on the bulls, measuring methane in bulls. This is University of Guelph, and they've also got the green feed machines. I went to visit this Alora station, that's part of the University of Guelph, a few years ago. It's incredible, that shed, with all those individual feed intake units. I think it was something like a K long. It's just mind-blowing to go in there. And they're taking measuring feed intake and methane very, very seriously. They coordinate an international project that we are part of called the Resilient Dairy Genome Project, and it's a fascinating place to go to. This is Italy. The Italians have got 2 different approaches. So this is the Italian Holstein Brown and Jersey Breeders Association. And they've got the green feed machines that I showed you earlier, and they've also got this sniffer technology or laser device that they point at the cow's nose to try and get an estimate of their methane emissions. Now, I asked how well it was doing compared to their gold standard, and they said, not too good, which I think in Italian means it's pretty crap. So they're still working, I guess, towards ways that you can measure methane at scale. But it just gives you a bit of a flavour, I think, of the different approaches. This is the Research Farm Dairy Campus in the Netherlands. CRV obviously having quite a presence both in New Zealand and also the Netherlands with measuring methane. And they have these individual feed intake bins, and they're also working with commercial farms to measure methane emissions using various technologies, but centred around sniffer devices. So yes, here it is. The sniffer devices actually fit in the astronaut, in their robots, their milking robots. And they're planning on getting 15,000 animals phenotyped by the end of 2023. So it's a really long-scale, long-term approach to automating the recording of methane. And if you're interested, there's actually some information on the Wageningen University website. So I think that ties in quite nicely to what Susanna was saying about the emphasis that the Dutch are placing in this space. So back to home, to Australia. Some of the things, the technologies that we're testing at Ellenbank right now are in the sensor device area. Through Fazelle, who's in the front row, I met Anirudh Desai, who is an engineer from La Trobe Uni, and he'd been working for quite a few years on developing wearable sensor devices for methane, in addition to accelerometer devices to measure feed intake, which is actually Fazelle's project. It isn't sheep, but we're actually testing the same technology to see how well it stacks up compared to our gold standard measurements at Ellenbank. So it's very exciting to actually have this happening right now using these sorts of devices. Talking of PhD students, this is the work of Boris Sepulveda, who is in the audience. I didn't see him, but I'm sure, there he is. So Boris is over here. Now Boris is doing his PhD with me and La Trobe, and he's also a DataGene employee. Now, he's got quite a diverse PhD project, but he has had a really great experience over the last 6 months or so with the trip to Spain to put together our rumen microbiome data with the Spanish data, and to actually look at the way measured methane compares to what we see in terms of the bugs in the rumen. Now, it turns out that if you're game enough to collect a sample of rumen liquor, which is that green, smoothie-looking drink in the middle, so that comes from the cow's rumen through the tube, basically. So you pass the tube down the esophagus and into the rumen, and you actually can get a sample that way. Now, the correlation between the microbiome, or an aspect of the microbiome, and the methane measurements is very strong and very consistent in the Spanish and Australian data, giving us confidence that if we can get a lot of these samples at scale, then we may actually have a way to give pretty good data for methane emissions from commercial herds. Interested to hear your perspectives on that. So, we could take whatever comes out of our Ellenbank experiment in terms of sensors, that microbiome data, or other predictors to genomic information nucleus level, so say GINFO, and use that as a way to develop our prediction equations. It's the obvious next step. We're a little way off being able to do that, but I hope that it eventually happens, because it's what really needs to happen to be able to make a difference from a breeding perspective. So, this probably feels a little bit backwards, but why should we care? Well, it is a really big deal, and I probably don't really need to emphasize this too much given the previous two speakers. But 95% of the methane from a cow comes out as burps, and livestock account for about 6% of greenhouse gas emissions. So one cow emits about 100 kilos of methane a year, and there are roughly 3.5 billion ruminants worldwide. So it is worth doing something about, and it is certainly worth collaborating on internationally. So what I would like to see is that we can eventually expand our methane breeding value to include methane genomics that comes ultimately from the GINFO population. So, Sustainability Index. This is a great, fantastic first step to reduce emissions intensity. And we really need to move towards a future sustainability index with real methane data. And I think data from Australian farms is very important to be able to achieve that, in addition to leveraging from collaborations with international partners. Now, I said I'd come back to the House of Wellness at the end. So one of the presenters said immediately afterwards, he said, anything that helps the environment is music to my ears. With that, thank you very much.
Thank you very much. Now, at this stage, I haven't got a Slido question, but is there anyone from the floor who has a question for Jennie, though? Obviously, you can catch up in a little while as well over lunch, but... Okay, well, I'll always take sounds of silence at these times because I'm good for time. But, you know, the three speakers here, I think there's a lot that's taken through the journey, examples, and now bringing this into our space in terms of the work that's being done here. And we're so fortunate to have the support of this research work to bring it to fruition. So I'd put your hand together and thank Jennie for the presentation.